All right, so things are looking up if you want a big snowstorm. All the models are showing a pretty big storm coming up the coast next week. The tracks are a little bit different. The amount of precipitation is a little bit different in some of the models, but they're all coming together, and the only model that really doesn't show a big storm is the American. The American still shows a decent amount of snow, but the Canadian and the Navy models are showing a really big storm. So is the European model. But just to give you an idea of how dire this situation is, I'm going to show you all the models. This is what each model is showing for Tuesday night. So there's your big area of low pressure. This is the American. This is the Navy. That's the Canadian. And that's the European. GFS, which is the American. So American, Navy, Canadian, European. American, Navy, Canadian, European. Okay, so you can see that's every single model is showing a huge storm. There's just a little bit of, and pretty much the track is the same for all of them. The GFS is just a little bit further to the east than the rest, and we'll go over why now. But we're going to use the American model now to talk about what's going to be happening. Okay, so here we go. We'll use this here. So we're going to go back to 48. Now, so what's going to happen is, after this piece of energy coming in along the northern jet stream moves off the coast, what you're going to have happen is you're going to have a surge of Arctic air come in behind this. You're going to have a strong area of high pressure setting up over the upper Midwest Ohio Valley towards the Great Lakes. And this Arctic air is going to dominate and set the stage for the big snowstorm. Now notice how far south this is going to go. You have a 1020 line, that's a pressure of 1020 millibars, 1020 millibars, coming all the way down south here. So that means your cold air is going to be all the way down into southern Georgia, I believe that is, I'm so bad with states, that is Georgia there, Alabama, and Mississippi, and even Louisiana. So the cold air is coming down really far south for this time of year, and this is really going to set the stage. So now you have a boundary between warm and cold air setting up down here, so you look for storms to form along that boundary. And we've got the energy coming in. So what's going to happen is you have this initial piece of energy. This is actually two pieces of energy combined. And with the western part of this big thing, which is right here, another piece of energy coming down across the Pacific Northwest. These two are already combined. Then you have another piece of energy that's going to come down and combine, and a third piece of energy that's going to come down and combine. So three different pieces of energy, and the last two pieces of energy are actually kind of coming down from this other piece of energy up here. So what's going to happen is this is going to move to the south and east, and this is going to form your storm down in the Gulf. So let's continue to move along. Alright, so now it's down into Oklahoma and Arkansas. There's your low pressure system forming over the Gulf states. And your precipitation map, you can see that there's rain and thunderstorms developing, along with the formation of the storm now. So if you continue to move east with this, those two pieces of energy combine, this piece and this piece, they combine now. And what you want to look for at this point is you want to look for this trough to become neutral to negatively tilted. When it becomes tilted that way, that's going to start to push the storm up the coast, right? So the quicker it becomes negatively tilted, the better chance there is of having a big snowstorm. So let's keep going here. Alright, you see now in the next model run, we're on Tuesday now. This is pretty much neutral, okay? This is a neutral tilt. And now it's starting to become negative by Tuesday afternoon. You see that? So your storm, which is on the eastern side of this here, by North Carolina, is going to start to come up the coast. Okay? And the more negative it becomes, what begins to happen, so this is, you see that negative tilt, what begins to happen is your storm begins to absorb moisture from the Atlantic Ocean and spew it back to the northwest with a negative tilt. So the more negatively tilted it is, the further west that heavier snow is going to be shot back. Now if you take a look at the old run of the American model, which I'm going to show you now, I want you to notice here, this is Tuesday night. This is the old run. There's the new run. It's not by much, but it is a little bit more negatively tilted in the new run. See that? It's more negatively tilted. It's a bit positively tilted still in this run. And so what you got here is the fact that since this is more negatively tilted, by the way, your third piece of energy is combining with the storm at this point. Although it's coming together just a little bit, looks like a little bit later in the old run than the new run, so that could be contributing to the stronger negative tilt if it's coming together a little bit earlier in the new run. And if you look at your precipitation map here, look at how far west this blue is getting in the new run, and then in the old run it stays a little bit further to the east. Not by much, but just enough where you can see the negative tilt is contributing to the moisture coming further west. Okay? So now, we're going to continue along here. So then this is when the low is closest to us. So let's look at our precipitation also. So there's a couple of things that this storm is going to be dependent on. The first thing is how negatively tilted is the trough. The next thing is when does this low begin to close off? What we mean when we say the low is going to close off is, so, you know, normally what happens is when you have the jet stream, your flow, your winds go from west to east, right? So generally if the low isn't closed off, that's going to cause it to continue an eastward progression. Now when this low becomes really strong, what begins to happen is when it closes off, it gets cut off from the main flow of the jet stream that goes from west to east. As a result, that slows down its progression eastward, and the slow can actually come further to the north rather than, you know, northeast. It'll actually start to show more of a northward turn because it's cut off from that main flow. And what that does is that allows the low to the storm to shoot moisture back even further west. It'll be able to wrap moisture around it, really heavy precipitation. It's going to be able to wrap around it and just throw it back over eastern portions of New England, extending back down into coastal sections of New Jersey, Long Island, and New York City. So that's another thing. So so there's three things here: the tilt of the trough. When does the third piece of energy combine with the other two that are already combined? Because if they all come together earlier, the low strengthens more, and it closes off earlier. And the third thing would be, when does the low close off? Okay, so this is what the American model has. It has the central pressure at this point at 976 millibars. It seems to bring the third piece of energy in just a little bit later than the rest of the models, so I believe that's why it's 976. It's not as strong yet. But if you take a look at the Canadian model, okay, here we go. Notice how you can see that the signature here for the closed low is a lot more potent than in the American model. Sorry, here we go. Alright, so Canadian model, American model, Canadian, American. You can clearly see that the signature of the closed low is a lot more potent here. It's more, this energy is more wrapped around in the Canadian model than in the American model. It's starting to wrap around in the American model, but the Canadian model says it's already going to be closing off. It's already going to be closed off by the time it gets southeast of Long Island. So that's what the Canadian model says. The Navy model agrees. So does the European model. Notice now, 968 millibars. The American model had 976 millibars. The Canadian model has 968, so it strengthens quicker earlier according to the Canadian model than the European model. And then if you look at your precipitation map here, notice you have heavier precipitation working back further west. If you look at your American model, you have the darker blue staying offshore. The green doesn't come ashore at all. In the Canadian model, you have your green coming ashore. You have darker blue coming ashore. You have a darker shade of blue coming across Long Island and New York City. Meanwhile, in the American model, you had a lighter shade of blue across those areas. So, because the low pressure system closes off earlier, according to this model is forecasting a significantly larger amount of snow in these areas than the American model is. Now, don't get me wrong. The American model is actually more negatively tilted than the Canadian model with the trough. And that's still going to be shooting moisture further west. But the closed low and the fact that it's stronger in the Canadian model is actually more of a factor in heavier snow making it further west and accumulating more. Okay? So that's the difference between the Canadian and the American models. If you look at the Navy model, again, so look at that potent signature. If you look at the Navy model, alright, here's the Canadian. There's the Navy. They kind of agree that the low is going to be closed off by the time it reaches southeast of Long Island. So again, there's your precipitation map. Long Island, just to give you a hint, is right in there. It's right on the western edge of this heavy snow here. So there you go. Now the European model shows something quite similar. The thing about the European model on this website is, the wind map is really not that good. I can't really tell what it's doing with the low closing off or, the tilt. I mean, I can clearly see a negative tilt here. So if it was up to me, I would say that there is a lot of, moisture coming back northwest as well in this model. And also, if you look at the low, 972. So this is also stronger and more potent than the American model. It has the same track, but the low is more potent. Look at all those isobars. I mean, look at that. That is just a really strong storm, according to the European model as well. So the European, Canadian, and the Navy models are all forecasting a larger amount of snow than the American model is at this point. But don't forget that the American model still has the most negative tilt. So, that's also going to play a role in the amount of snow. Alright, so now that we've looked at all the models, in the next video I'm going to go over my threat map. Okay? But first, what we're going to do here is we are going to, first I want to show you what what we call the WPC, the Weather Prediction Center, is predicting. This is on NOAA's website. This is what they're predicting for the storm. I think they're actually going to shift this a little bit farther west based on the new model runs. This is a little too far to the east. I think the models are trending a little bit further west. Then if you look at our QPF forecast, they still haven't... Oh, they did change it. Okay, so now take a look at this. Now your QPF forecast, again, gives you the liquid equivalent of what we expect from, if it was to rain, what would the liquid equivalent be from that rain? Now, what they have forecasted here is from the storm they have a 1/2 inch to 3/4 of an inch of liquid equivalent, over eastern portions of New England here, extending back into New York City, and then central Long Island, and then you have 3/4 of an inch up to an inch, perhaps. And then on the Twin Forks, you have up to 1.25 inches. So that's a lot. So if you have snowfall ratios of 10, you multiply that by 10, you would get up to 1 foot over the Twin Forks of Long Island. You would get, oh, actually, you know what? I got to stop this and continue in the next video because I can't go over 15 minutes. So next video will continue.